Next, we are going to talk about tree diagrams. Now, tree diagrams are leading up to the fundamental counting principle, but I think the tree diagrams are a real easy way to sort of introduce us to this concept, and also a pretty common thing to use, especially if you don't remember the fundamental counting principle. So I like tree diagrams, and I think you will too. All right, so this first one, use a tree diagram to find the sample space for each event. State the number of possible outcomes. So when you make a tree diagram, what you do is you look at what the options are and you kind of sort of list them. So we got a spinner. It says the spinner at the right is spun and 2 coins are tossed. So we got 2 things going on. So we have a spinner, right? So I'm gonna make a column here that says spinner. All right. And then I'm gonna say coins. All right. And then we're going to look at what the options are. So here's the thing. For the spinner, right, I've got A, B, C, D, and E, right? So I've got red. All right, and 2 coins are tossed. So we're going to actually make this coin 1 and then coin 2, right? Because 2 different things can happen. So we've got red, we've got yellow, and we've got green, purple, and blue. And then for red, and this is where it gets really interesting, for red you can have heads or tails, right? For yellow you can have heads or tails, and you can have that for everything, right? For heads or tails. And I think we're gonna run out of room with this. Heads, tails. I'll put this over here. Heads, tails. All right. Then for coin 2, for this option, you can have heads or tails. For this option, you can have heads or tails. For this option, you can have heads or tails. For this option, you can have heads or tails. And then for this one, and then you go forward, and you know it's kind of tedious, but you're hopefully getting the idea of this, right? So you can have heads or tails basically for all these different things, right? And these are all your different options. So you start with your color and then you branch off, and then pretty much it says state the number of possible outcomes. The number of possible outcomes is always going to basically be what you have in your last column on the right. So I would say, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 outcomes, okay, is what this is telling me if I did this right. But I didn't do it right. I missed something here. So you guys got to tell me this. Heads, tails, and then this one. All right, so I have 20 outcomes because I added 2 more. All right, now what's cool about this, and I'm going to kind of lead into the fundamental counting principle with this, is there's 20 outcomes, right? Now, if you look at how many possible outcomes were there for the spinner? Well, there were 5, right? How many different outcomes were there for the coin? 1. There were 2. And how many were there for coin 2? There were 2. I wound up with 20 things. What happens if you multiply 5 times 2 times 2? You get 10. And you get 20. And so there's a direct corollary there, right? That's intentional. And kind of without trying to, we've sort of discovered the fundamental counting principle, right? So we're gonna do one more tree diagram, but just so you know, these tree diagrams, once you remember how to do it this way, the tree diagrams are just cumbersome and annoying. All right, so how many different 3-character codes are there using? A, B, or C for the first character, 8 and 9 for the second, and 0 or 1 for the third character. All right, so we got A, B, C for our first one, right? So we got A, we got B, we have C, and then we have 8 or 9 for this one, right? So we have 8, 9, 8, 9, 8, 9. So doing good so far. Plenty of room. And then we have 0 or 1 for the third character, right? So 0 or 1. So you've got 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. And then these are all your different options that you can have for this. And then if we apply the fundamental counting principle, well, first of all, let's see how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 possible character codes, right? So 12 possible codes. If I apply the fundamental counting principle, right, our first option is 3 different, and then 2, and then 2. And 3 times 2 times 2, well, 3 times 2 is 6, 2 times 2 is 12. So it works. The tree diagrams kind of set it up and sort of put the ball on the tee to show you how it works. And then we use the fundamental counting principle from here on out, because as much as possible, because it just works better and it's so much easier. All right, let's move on to that.